Scenario. A car can crash on a wall with 500,000 Newton force in a matter of seconds. Question. Assume the collision took 2 seconds. What is the change in the car's momentum? The answer. We'll start off by setting up the equation. Delta P is equal to the force times delta time. Delta P stands for the change in momentum. Delta T stands for the change in time. Plug in the values. 500,000 goes in for force. The delta T is 2 seconds. You now get the value of 1.0 times 10 to the 6 kilograms times meter second. Question. In modern cars, there are airbags. How does the airbag affect the change in the person's momentum during the car crash? Hint. Think about what variable is changing in the equation. Answer. The delta T will actually increase. It lengthened the stop time of the person, as a result, reducing the force applied during the collision, assuming that delta P is still constant. That airbag increases the change in the time. So the time it takes the head to collide with the bag with the airbag takes maybe 4 or 5 seconds. That is an increase in the time. When time increases, the force has to decrease. So the amount of force the person feels is actually less. This leads us to the third question. What is the force of the car crash on the wall if the change in momentum of the car is the same, but now the time doubles? So let's say it's at like 4 seconds now. Okay? So the momentum is the same, which is 1 times 10 to the 6. The new time is 4 seconds. Divide by 4, you see that the new force is 250,000. Notice it is half as before. The fact that you doubled the time, you feel half the force. This is great. This is the reason why airbags work, is because it lengthened the stop time for the collision.